Let's take a look at what waves are. Now, you experience waves a lot in your everyday life. Both sound and sight are the result of waves traveling, whereas at the large level, taste and touch aren't usually waves, although you can feel the heat from a lamp. We think of waves, we think of light waves, we think of sound waves, we think of water waves. All of these are different types of waves. So, what is a wave? A wave transports energy through a medium without transporting any matter through it. Okay, when we think of a sound wave, what we hear is we hear energy. Right? There's energy from a sound source. It travels through the air to our eardrums, where our eardrums is moved by the energy of that wave. So a wave, typically there's 3 parts to a wave. Well, here's some parts to a wave. We have a source, which provides the energy. Now, when we think of a source, we can think of a speaker. And a speaker cone often looks like this. It's got a little bump in the middle, and it's shaped like this. And then it's got a magnet back here, like that. That's the source of our wave. This cone vibrates back and forth. That vibration back and forth is energy being transferred to the medium. So we've got our source here, we've got our medium. In this case, the medium carries the energy. So we often can think of waves as like kind of these lines spreading out. So in this case with the speaker as our source, air is our medium. Our medium is air. Now the air doesn't move from one place to the other like the wind does. The air vibrates back and forth. The air molecules kind of vibrate back and forth. And the energy is then transferred over to something that can receive the energy. So in this case, we have an ear. So here, so we have our source, we have our medium, and then we have the thing that receives the energy. So we can think of waves, they're what? The waves are in between the source and the receiver. The wave transfers the energy of the source, transfers it to the receiver, and the medium doesn't get moved from one place to the other. It doesn't displace from one place to the other. The medium, it will have a disturbance go through it, and then it will go back to where it was before. So the wave part is this disturbance. The wave, this disturbance. It's this transfer of energy from the speaker to the receiver. I mean, there might not be a receiver. The wave just might, run out. But it's this energy in between. And the energy is caused by a disturbance in the medium. It doesn't move the medium from one place to another. The medium kind of vibrates and then goes back to its original spot. So where do we find waves? All right, well, the first, sound waves. Now, sound waves can have a variety of sources. So sources like somebody's voice, speaker, just something rubbing on a material. So any moving thing, basically anything moving on a material can cause a sound. The medium is air. That's what. And a common receiver for sound energy is an ear or microphone. Now, it doesn't have to have this for the wave to exist. The wave will exist without a receiver, but the only way we can study waves is if we receive them somehow. So sound waves is one. Light waves. Well, where do light waves come from? Well, lights, the sun, lots of places. They come from vibrating charged particles. Electrons or photons. The medium for light wave. The medium for the light wave is called the electromagnetic field. And what receives light waves? Well, our eyes do. Cameras do. There's lots of different things that can detect light waves. You can feel heat. Those are a few of the things that can detect light waves, or light waves disturb these things. So we've got light waves. It's a disturbance in this medium that doesn't cause the medium to move, but causes energy to flow through it. Right, so water waves, another common set of waves. Water waves can be caused by the wind. The wind blows across the lake, and the waves. It can be caused by moving earth or moving object, like a tidal wave would be caused by plate tectonics moving, shifting around under the ocean. An earthquake can cause a water wave. Something dropped in the water. Can cause a water wave. The medium for the water wave is the water. You see a disturbance in the water, but the water isn't really moved from one place to the other. The water really just goes kind of up and down, and then it goes back to its rest spot. And what detects water waves? Well, anything like you can feel. Or stones move. The water can transfer the energy into a stone. There's lots of different ways that energy can be transferred into a lot of things. So, what makes waves so important? Waves are very important. Most of modern life is built on the ability to create and control waves. Waves. They allow us to sense things at a distance. Right? If you think about somebody sneaking through a house, making little sounds, you can hear those sounds at a distance without having to be too close to the person. And it might alert you that that man is in the house trying to kill you. Or it's just a friend making a practical joke, pretending to try to kill you. We don't have to be inside the sun to sense the sun. We can sense it at a distance because we can see the light that it makes. We can feel the warmth. So, allows us to sense things at a distance via sight and sound. Waves allow us to transfer information. We use light waves, electromagnetic waves, to transfer information all the time. Inside your cell phone, there's a radio transmitter. That radio wave sends a signal of energy out through the electromagnetic field to get picked up by the cell tower, which can then communicate with the rest of the world. So you can transfer information back and forth via waves. And that is probably their biggest use. For us, we're starting to be able to transfer energy at a distance some people are considering things like putting up giant solar panels in Earth's orbit and then you could use microwaves or lasers to beam the energy from those solar panels down to Earth. Or there's proposals to have a spaceship that's flying long ways away from Earth to shine giant lasers at it to provide it with energy. The sun transfers a large amount of energy at a distance. The sun provides about 1,000 watts of energy per square meter for the Earth. And we use that energy to photosynthesize, to produce sugars, to warm the Earth, to allow life to live. So it allows to transfer large amounts of energy at a distance. All right, what causes a wave? Every wave has a source. And that source has some type of vibration or periodic motion. Right? So in a sound wave, so inside your throat, there's something called your vocal cords, which kind of go like that. And your vocal cords have muscles attached to them. And when you breathe through your vocal cords, your vocal cords start to vibrate. So they vibrate back and forth. And when they vibrate back and forth, they cause sounds to happen. You can tell this by putting your fingers on your throat and talking. You can feel the vibrations through your fingers. And then as the air goes through, then the air has the vibrations in it. The air is vibrating, and the air comes out of your mouth vibrating. So the vocal cords are vibrating. They have some type of a periodic motion, back and forth motion, and that causes a sound wave. In light, you can get light in a very simple way. If we've got a simple molecule here, and a molecule has different electron orbits. So here's an electron. If we put some energy into that electron can jump up to a higher orbit. But after it jumps up, so some energy in, and the electron jumps to a higher orbit. Now that might be electrical energy. And then, at some point in time, that electron, which is now at a higher, will fall back and it'll lose energy. Then the electron falls back and it emits light. So the electron falls back to here and it sends off a light wave. So by causing this vibration, this motion in the electron to happen, we can send off light. Even if you just run electricity, if you take a transmitter tower, like you've seen telephone towers, big ones, transmitter towers like this, and inside them there might be a long metal rod, a transmitter. If you send electricity up and down, so you vibrate electricity in this, vibrate electricity in this tower, electricity, it will send off radio waves. All of these are caused by a vibration or a periodic motion at the source. And the energy from that vibration or periodic motion sends off a wave of energy out through the medium. Right? The vibration of the vocal cords starts a sound wave traveling through the air, which travels up your voice box, up your throat, through your mouth, and out. And that energy from that vibration gets transferred all the way across to someone else over here who's listening to it. Right, so this should give you a simple idea of what waves are. We're going to look at how we, at their characteristics in the next video.